Here we go. We're going to jump on this. Start up right away. In number 1, it says our points A and E collinear. Do you even need to look at the picture? No. Why? Because it's 2 points. Any 2 points are always collinear. My answer is yes. If you don't have yes written down, you should fix it right now. We don't like giving out zeros on practice problems because people aren't paying attention and changing things when you have them wrong. Fix them, please. Are AE and C coplanar? How many points are always coplanar? Do I have to look at the picture? No, 3 points, always coplanar. Answer is yes. Make sure those both say yes. There's no work there. You just got to make sure they both say yes. All right, now we need 2 lines that are skew to EH. Now, there are more than 2 lines, so I'm going to list them all up here, but you are not going to give me all of them. You're only going to give me 2 of them. So I'm listing them all to make sure that the 2 that you picked are listed. Yes, go. DC. And I have a line symbol over the top. Why is it skew? What does it take to be skew? Perfect. Non-coplanar, not in the same plane. Don't intersect, but not parallel. The only way not intersecting and not parallel happens is if they're in 2 different planes. Okay, so there's one. Somebody else give me another one. AB. Somebody else give me a different one. BF. Somebody else give me the last one. Very nice. I don't care which 2 of them you have, but make sure you have 2 of them. Only 2 of them, not 4 of them. Because it asked for 2. We answered the actual question. Also, make sure you have the line over the top with the arrows on it. Make sure your symbols are there. All right, now I want to know where planes EFGH, so that's EFGH, and AB intersect. EF, what is EF? A what? So I have to have a line over the top of it. Lines have to have lines over the top of it. Did you have to look at the picture for that one? Not necessarily. Why? Perfect. All 4 letters are here, so I can just find the 2 that are in both of them, because you know that's the line they intersect on. That happens when all 4 letters are there. If they're not all there, you might have to look at the picture, because I might not have given you both repeaters. All right, now we need 4 different rays that are shown in this picture. Give me a ray. BA. Rays need to have that ray symbol or that arrow over the top. I'm just going to put a mark over here. We did BA. What else? Somebody else talk to me. BC. So starting in B, going past C. Okay, give me another one. Say it again. AC. Starting at A, going past C. Okay, could I have called that something besides AC? Yeah, AB. So that's an OR. You can have one of these, but not both of them. It is either AB or AC. So if I start at A and I go out here past C, I passed B on the way. So it doesn't matter which one of those letters you use, you are already passing them both because it goes forever in that direction. Okay, give me another one. CA, going this way. So there's another way I could have named CA. What would it be? Very nice. Again, you are double checking here that you have 4 different ones. You got to have BA, you got to have BC. You only get one of AC or AB, one of CA or CB. Okay, so 4 different ones. And before we leave this question, it says to circle the opposite rays. What is an opposite ray? What does that mean? Yeah. 2 rays that go in the opposite direction forming a line. Okay, which 2 go in opposite directions forming a line? BA and BC. If you don't have them right next to each other, you can circle 2 separates. That's fine. Remember, opposite rays have to have the same endpoint. So they had to be the ones that started with B. All right, last but not least, we got this ACT review. Now we look at this question, and it's got square roots in it. And really great reaction to square roots is to get rid of square roots, we do what to them? What do you do to both sides if you want to get rid of a square root? Square them. There's one big problem with this. You've got two different square roots on the left-hand side. If I try to square that side, I actually have to end up double distributing with square roots in it. Yucky. Okay? Not something, one, that I even make you do when you get to Algebra 2, but two, that's not something you've covered yet. But this problem can show up on a pre-ACT and you can still do it. Even though the algebra part of it is more advanced than where you're at, the test-taking skill is not. You've been given 5 possible solutions. How do I check if a solution works? Put it in for X. You don't need to know how to do the math behind this, the algebra behind it. You need to know how to plug a number into an equation and see what you get back. You also need to know how to work your calculator. What answer? Let's go. F is 1, G is 2, H is 3, J is 4, K is 5. Show of hands. What did you pick? 1, 2, 3, 4, or 5? I got 3s out there, 1s, and people who didn't answer it yet. I got a 4 out there. Okay. How would we plug the number in? What do you have to do? Go. Okay, so give me a number to start with. Which one of these answers? 25? So I put the square root and I got the 25. And we're checking to see if it equals 8, right? Now, some of your calculators may not have given you 8 back. Here's why. Your scientific calculator brings up square root with a parenthesis sign, right? Then you type the 25. This equation wants me to stop taking the square root before I add. You need to tell your calculator to do that. You need to put the parenthesis on the other side of that 25 so it stops and says, okay, what's the square root of 25? Then it's going to come over here and it needs to do 25 minus 16 first, then take the square root of that, and then add those two numbers together. Okay, so H is the correct answer. Proving it by showing that you put 25 in, you'd get 5 plus 3, which is 8. You could just write 8 equals 8 there because that's what I told you checks are in this class. Put it into your calculator, but I need you to remember how to use your calculator. You have to give it the extra parenthesis right there. That's the one that matters because that second one, you're hitting enter at the end after the 16 anyways, so it's good to do everything that's underneath it. Good? All right. When you have shown me work on number 6, some of you may have more than just that one because maybe you tried different ones. Before I go here, ACT always puts the numbers least to greatest. So if you are looking at a problem where you have to plug numbers in to check which one's right, I usually start in the middle because then I know I can look at it and go, okay, I'm too high. I can eliminate 2 other numbers besides just the middle one. Or I'm too low, I'm going to eliminate the other one. So you just got to be able to reason through, okay, if the number I got back here is too big, what kind of number do I need to put in there? Bigger or smaller to make this value change. So you should be able to, if you go to the middle one first, eliminate 3 out of your 5 answers just by plugging in one number. Does that make sense? Okay. Double checking that you showed me work on number 6. Double checking your symbols in number 3, 4, and 5. Making sure you've got lines on 3, a line on 4, and arrows on 5. Then you're going to make sure it's 100% correct. Put your name on, passed up. Make sure you circled your opposite rays in number 5. right, we are looking at section 4 today. In section 4, we deal with a little bit of the algebra and the geometry combined. First thing we got to talk about is distance. Distance between 2 points is always what kind of number? Positive. Very nice. We have in math an operation that takes a number that's negative and turns it into a positive. It is called absolute value. The distance between any 2 points is the absolute value of the difference of the numbers. Why? Because absolute value measures the distance from 0, and distance is always positive. So when I want to know how far it is between 2 points, maybe I have a number line and I can just count it, but maybe I just know locations. And if I know their locations, I can subtract their locations and then take the absolute value of that subtraction. And I'm going to show you how that works. We have A at -3 and B at 21. So if I want to find the distance between those two, I can take -3 minus 21 inside that absolute value. But what is -3 minus 21? Come on, -3 minus 21. Nope. I'm $3 in debt and I lost $21 after that. How far in debt am I? -24. I am now in debt $24. But I want to know how far away from 0 am I. What do I need to make to be out of debt? 24. So absolute value is always positive. If that messed with your heads because of the negative, flip it around. I can do 21 minus -3. What happens when we have minus a negative? You are adding, so we get just the positive 24. How far away from 0 is 24? Still 24. So that is why this absolute value thing works, is that no matter which way you do the subtraction, you're still going to get the positive answer. Does that make sense? Okay, what I want you to think about, if that subtraction thing is kind of messing with you, is think about the number line. If I got to get from 3 to 0, -3 to 0, how far do I have to go? And then I have to go another 21 to get to my value. So it's how far do I have to travel between the two numbers. You can always use the number line that way as well. So I go up 3, then another 21, I go a total of 24. Good? All right, you're on those next 3. Ready, set, go. The absolute value and come back up with that positive number. Distance is always positive. And once you have those 3 answers, check with somebody near you, see if they have the same. If they don't, see if you can convince each other. All right, what do we have for 2 and 9? 7, because we had 2 minus 9 or 9 minus 2, doesn't matter. Absolute value of negative 7 is positive 7. Maybe you flipped it around, did 9 minus 2, that's totally fine. You got the 7 right away. How about this next one, though? 6, but I saw 10s out there. How did you mess up? What's this? Why would it be 6? I don't get it. Why do we do negative 8 plus 2? I'm hearing subtracting a negative. Absolutely. We've got minus a negative 2, which is plus 2. So the absolute value of negative 6 is positive 6. Other thing to think about here. Look at the number line. 8, negative 8 to get to 0 would be 8, right? So does it make sense to go from negative 8 to 2? I had to move 10? No, I didn't get all the way up to 0, and it would have taken me 8 to get to 0. So you got to stop and think, does my answer make sense? It doesn't make sense when it's 10 because you were not that far away from 0 to begin with. All right, last one. What do we got? 19. Somebody else tell me how. Negative 8 minus 11 gives you? Which gives you an absolute value of positive 19. Now, all of those, we did the left number minus the right number. I'm going to point out again that you can do the right minus the left. So if you looked at that first one and went, I don't want to deal with a negative, and just did 9 minus 2, it's the same deal. How far do I have to move to go from the left to the right is the same as how far I have to move to go from right to left. Not a big difference either way. Good? All right, beautiful. So down below that, we have something called congruent segments, and that's congruent just means same, right? Yes? So congruent segments are two segments with the same length. The symbol for that is an equal sign with a little squiggle over the top. Tilde if you're in Spanish. And we can see that congruency in a couple different ways. It might actually be listed on the picture and just shows AB is 2 centimeters, CD is 2 centimeters. This is how we'd write it out. We'd say a segment AB is congruent to segment CD. You got the segment bars over the top. Can lines be congruent? How long is the line? Infinite. So we can't talk about lines being congruent because we don't have an actual measure for them. Infinity doesn't count as a measure of length. Okay, so we've got AB is congruent to CD. What we can do, and what you might sometimes see in notation, is the segments are congruent. This deals with segments. If I want to talk about their lengths, sometimes you will see no segment bar, no congruent symbol, and it'll just say AB is equal to CD. Typically speaking, that notation means they're measures. So the actual values of those numbers, as opposed to saying, I'm looking at two segments and I know they're exactly the same. This is say I know that their measures are the same. So it's just a different notation. You want to focus in, I want you to focus on having segment bars and having congruent symbols. Okay, when we work on the algebra problem, I'm not going to worry about whether or not you have the notation on those. Good? All right, when we look at a picture, these tick marks mean congruent. So I might see 2 tick marks on AB and 2 tick marks on CD. I know those two are congruent to each other. My picture might have another set of segments that have 1 tick mark on each. Those two are congruent to each other. So you match up the number of tick marks to figure out which ones go together, which ones are paired. Does that make sense? Okay, so you know what congruent segments are, yes? You know how to figure out how far it is between 2 points on a number line, yes? So turn to the top of the next page. Look at this picture that I left on this page. And figure out, write down for me 2 segments that are congruent. So looking in that picture, figuring out numbers on that number line, give me 2 segments that are congruent to each other. There are multiple answers here, so you may not have the same as somebody near you. All right, we've got two different options here. Give me one pair. How long are AB and CB? Does it matter? He said I meant BC. Does it matter if I say BC or CB? Nope, because segments can be named in either direction. Thanks for bringing that up. How long are those? 3. So we got 3 to here, 3 to there. Somebody else give me a different pair. DC, okay. Congruent to DE. How long are each of those? Yep. So it's just being able to figure out that distance between the points and throwing it into a congruent statement all at the same time. Good? All right, then we're going into a postulate. Postulate 1.6 is a segment addition postulate, and in it says, if 3 points are collinear, what's collinear mean? On the same line, thank you very much. 3 points are on the same line, and B is between A and C, then AB plus BC equals AC. I'm going to guarantee, without all the algebra words or the geometry words there, you would probably completely agree with me on this statement. I'm going to show you why. I have AB right here. Yes? I have BC right here. What happens when I add the? You get the length of AC. That is all this postulate says. Take the two little parts of the segment, add them together, you get the whole segment. That makes sense, right? That's why it's a postulate. There is no proof involved in this. We just looked at it and went, duh. You add the two little parts to get to the big part. Okay, so now let's take that duh moment and put some algebra in it. When I look at this next picture, it tells me that dt is 60. ds is 2x minus 8, and st is 3x minus 12. Give me a geometry concept or something I could do with those facts. Equal them up to each other. Equal what up to each other? Okay, so I think you've got two statements in what you just said. So we said to equal them to each other because no matter what, they equal up to 60. So somebody else, let's tweak that a little bit. Go. There you go, because no matter what, they add up to 60, so we got to add them first. So I'm going to write it in geometry first. We are saying that ds plus st equals dt. And now we're going to throw that algebra in. ds is 2x minus 8. I'm substituting into the geometry statement. I'm substituting the algebra in. Plus 3x minus 12. Do I need parentheses around that 3x minus 12? If I put them there, are they going to make any difference? No, because I don't have to multiply, right? There's nothing to distribute, so I'm just going to leave the parentheses off. And then that equals 60. First step, find your equal sign. Do we need to start moving things side to side, or do we need to combine like terms? Combine like terms. There's all sorts of stuff over to the left of that equal sign. Let's simplify it. Let's make that side easier. So what do I combine? The x's and then the numbers. Okay, so what do we get when we combine like terms? 5x. Okay, somebody else tell me next step. Go. Adding 20 to both sides, keeping that equation balanced. I now have 5x equals 80. Divide by 5. What's x? Am I done? No, why not? Very nice. We got to plug it back in because it wants ds's length. So I'm taking 2 times 16 minus 8. How long is ds? $24. Guys, remember, you don't have to raise hands for me. Just start talking. I love it when people are talking because I know you're doing the math and you're working with me. Now, somebody new is going to tell me I got 3 times 16 minus 12. I'm seeing mental math going on. I got calculators. What do you got? How do I know if my answer is right? Add them together. Absolutely. What is 24 plus 36? 60. Beautiful. We did it right. Questions? All right, you're on the next one. Go. All right, so we've been around. We've looked. We had an X of 15, an EF of 40, and an FG of 60. And 40 plus 60 does give me 100. So everybody had that. Does anybody need me to go through any of the work on it? All right, beautiful. Let's turn the page. On the next page, we have another definition. It's a midpoint, a point that divides a segment into two congruent segments. We can either be told it and just be said that M is the midpoint, of AB, or we might have it on the picture with tick marks, which would tell us that segment AM, is congruent to segment MB. And again, whichever order you put those letters in doesn't matter. Okay, so sometimes it's on the picture with tick marks, sometimes it's on the picture with the words, so you have to recognize that you can put the tick marks on. It just goes both directions. You have to understand that midpoint means it's a point directly in the middle, two equal parts on either side of it. And when we have that midpoint, we can have things called segment bisectors. It's a line, a segment, or a ray that goes through the midpoint. So anything that crosses through the midpoint of a segment is a segment bisector. Bisector, and I'll ask you this over and over again this year, bisector is something that cuts it in half. If it bisects, it cuts in half. So on that picture, I could draw in a line that goes through point M, and there is a segment bisector. I could make it a segment. It wouldn't need to have arrows on it. It could just be the segment. It could be a ray. As long as it hits point M, it doesn't matter to me where it is or what it is, because it is on the midpoint. And I just put the tick marks on there to show that it was at a midpoint, because we had those two equal parts. Is that okay? So what does a midpoint do to a segment? Cuts it in half. Absolutely. A bisector cuts it in half. The midpoint's at that halfway point. So when I look at this next one where it says find X, and over to the side it tells me C is the midpoint, what does that tell you about the picture? Cuts it in half. So what do I know is true? Say that one more time for me. If I add them together, absolutely. So we know from the last part, I can do this. That's your segment addition postulate. Now use that midpoint word to give me more information about this segment. They're equal. What's equal? Perfect. Because it's a midpoint. AC and CB are congruent. Which one of those two things is more helpful and lets me solve for X here? The one where we add the two littles to get to a big, or the one where I take the two parts and set them equal? What information do you have in the picture? Do we have a total? So can I use the first one? No. So I can't use this one. I've got to use this one, because you don't need a total. We're not given a total, so we got to use the rule that we have the information for. Does that make sense? Because you're going to see that on your assignment. You're going to have to look at which one of these things from our notes today am I supposed to use here? You got to stop and think, do I have a total? Then I can add the two littles to get to the big. But if I don't have a total, I can't get to the big. So I have to use the fact that it's a midpoint, which means these two are equal. So set me up an algebraic equation out of that. Using this one. Thank you. There you go. Got to set them equal. We can't add them together because we don't know what they total. All right, where's that equal sign? Okay, it's in the middle. Do I have things to condense on either the left or the right side? Is there a lot of stuff over on one side or the other? No, so then I need to start moving things, x's to one side, numbers to the other. No combining like terms, now I'm moving those terms. What goes where? Add 4 and minus 2x. I'm going to do those in 2 separate steps. You're absolutely right, but I'm going to do them 2 separate just to keep it clear for everybody what's going on. So we added the 4, and then we subtracted the 2x. Now remember, I'm doing it in 2 separate steps. That doesn't mean you have to do it in 2 separate steps. You can move yourself straight to that 5 equals 1x right away. You go ahead. You got to show me something, though, from the start to the finish. So show me what you, this one I might actually write it underneath just so I can see if you're going to do them all in one step. Because otherwise you jump right to the answer. Then the problem asked me to find AC and CB. How? Plug 5 in for x. So AC, I've got 2 times 5 plus 1, which is? BC, I have got 3 times 5 minus 4. What happens if they're different? You didn't do it right. What do I do then? Do I just stop? Be like, yeah, oh well, too bad. They're not the same. Go back and check your work. Figure out where your mistake was. Because you know there's a mistake there. So you got to find it, fix it, so until you get them to equal each other. Questions? All right, are we okay if I move off this one? Yeah. By the words that they give you. So we tell if we had to split them or set them equal to a total by the information that's given in the problem. This one gave me midpoint, so I knew I could say those two are equal. The last ones gave me a total. Then I'm looking to add them up and equal the total. Everybody okay with that? Okay. So on this next one, we've got AB is 4x plus 16 and AM is 20. Tell me what we know in the picture before I start writing things on it. Yeah. Before I write things, what else do we know in the picture? Like generic picture before I look at the algebra stuff that's written off to the side. M is the midpoint for both lines. How do we know that? Somebody else? Yeah. But does it have to be that then? Like, couldn't I have, just because it crosses there, would that one be the midpoint of both lines? Am I guaranteed a midpoint if 2 lines are crossing? No. How do I know it is the midpoint in this picture? They both have an M no matter what, if it's crossing at M. Something special on this picture. Go. What are those lines? Like these lines? Yes. Tick marks show me they are congruent. If the tick marks show me congruent, then I can say it's a midpoint. I can't just assume 2 lines cross, it's in the middle. You've got to see the markings. All right, so now I'm back to these actual things. We have AB is 4x plus 16, and AM is 20. This actually combines multiple things from what we just learned. What can we do with it? Or what else do we know besides those facts? Perfect. Tick marks tell me these are the same. Okay, somebody else take me another step. What can we do now? Anything you know on that picture? All right, 20 and 20, AM plus your MB. That's 40. But that's the same thing as AB, right? All together? and AB is the 4x plus 16. So a lot of times what I'll do here is I'll write the geometry and the algebra kind of simultaneously to show you you're using the algebra to help you figure out the geometry. And you're using the geometry to set up the algebra. Okay, so we've got that if you take those two little pieces and add them up to the total, that was our segment addition, that it equals the whole thing, 4x plus 16. But you also had to use the fact that the midpoint was in the center and those tick marks meant they were the same. Okay, next step. So 4x is, and then, and what do we get? All right. Doesn't tell me to plug it back in, so we're just going to be done with that one. Now I want to look at the one next to it. This time, it gives me that AM is 5x minus 1, and AB is 38. I want you to see what you can do with that before we talk about it as a whole. So go ahead and look at that problem and see what you can do with AM is 5x minus 1 and AB is 38. Ready, set, go. All right, we got some different answers out there. Talk to me. Give me something you might be able to do. Yeah. Okay, somebody else give me another thing you set up. What will that equal? Okay, yeah. So far, have we written anything different? No, those are all the same equation, right? Okay, does anybody have any different one than that? Okay, explain to me where this one comes from. Yeah. Because if AM is 5x minus 1, MB is 5x minus 1. So we have two 5x minus 1s. Or we have 5x plus 1 or minus 1 plus 5x minus 1. It's two 5x minus 1s, right? And then we add our like terms, and we get to 10x minus 2. Or we distribute, and we get to 10x minus 2 equals 38. Are we okay with that? How would we solve that? So we get 10x equals 40. X equals 4. Okay, so that one, we multiplied the one thing times 2 to get to the whole. What could we have done to the whole to just get back one 5x minus 1? Divide by 2. So we could have done, I'm going to put it up here, 5x minus 1 equals, if I do 38 divided by 2, that's 19. And we would have gotten the exact same answer because 19 plus 1 is 20. Divide by 5? 4. Same answer. What you have to do is you look at a problem, you got to go, okay, is it easier for me to take the whole and cut it in half and just set the halves equal, or to add the 2 halves to get to the whole? And a lot of times that depends on what kind of number the whole is. If the whole is an expression, like a 4x plus 16, I don't really want to cut that in half. It's too much algebra-ness. But if the whole's a 38 or a 40 or a 20, that's easy to cut in half. Maybe I do want to do that. So you just got to look at it to analyze which one's the easier way to do it. Does that make sense? All right. So now, next side, you have 4 problems. You're going to get together with somebody. We're going to go for about 5-ish minutes and see what you can get through on that. So 1 through 4, go ahead and find yourself a partner. Or multiple partners. First answers are up there. Number 3 is up there for you. All right, the last one I want to talk about real quickly, if I could please, because then we got to move from there. So if we can look at number 4. Everybody look at number 4 for me, please. A is at -6. B is at 2. So you're on a number line. Where's the midpoint going to happen? In between A and B. So can I eliminate an answer right away? Which one? -3. -3 is in between those. 4. 4 is not in between these two numbers. But I bet you a whole lot of you circled 4. Why? Where's the 4 coming from? Absolutely. Right here, we've got 8 apart. Midpoint's halfway. We divide by 2 and we get 4. And we're like, hey, there it is. Oh, wait. 4 is how far it is to the midpoint. 4 can't be the midpoint. It's over there. Can't be that one. Where is 4 away from -6 or 4 away from +2? -2. Okay, so again, multiple choice test taking skills. The first answer is going to be there because they want you to pick the wrong answer. Those nasty test makers. Pick the right answer because you take that next step. All right, we're back to our desks. Hopefully you have a protractor in your hands because we're going to need that momentarily. All right. Going to go with things I'm pretty sure you know what they are. An angle. An angle is formed by 2 rays with the same endpoint. The sides of the angle are the rays. I'm going to put 2 in front of it just to make sure that we're clear. The vertex is the endpoint. That common endpoint. So if I look at this next picture, what are the sides of the angle? I want to know what kind of angle it is. What object is on the side of the angle? Remember I said the sides were rays. It's not a line, it's a ray. Where does it start? B. What does it go past? T. There's a side. Ray BT. Give me another side. BQ. There it is. What's the end point? What's the vertex of this angle? B. Perfect. When we name the angle, we can name it in a bunch of different ways. We can name it with the vertex only. So I can call this angle B. So this little symbol here that I had up by the word angle, we put that in front of the letter to show that I'm talking about an angle, not just a point. I could name it if there's a number in there with the number. So I can name it angle 1. Sometimes, though, neither one of those is a very good name, so we name it with 3 letters. The vertex is always in the middle, so I can start with T, go to B, and come to Q. So TBQ. Or I can go the opposite way, QBT. Important part is that the vertex is in the middle. Now you're probably saying, why would I name it with 3 letters when I could name it with 1? So I look at the next picture and I ask you, how many angles are in that picture? I heard 2. And I hear 3. So those 2 people can't tell me why. Somebody else tell me where the 3rd one, because how could she see 3? They only saw 2. Absolutely. You got the 2 littles and you got the biggest one. So is angle E a good name for any of them? Well, you know which angle I'm talking about if I say angle E. No. That is why we have to have the ability to name it with 3 letters so we can give a good name that tells you exactly which angle I'm talking about. So I have angle 1 there. I'm going to trace angle 1 just to make it clear. Give me 2 other names other than angle 1 that I could call that. Give me one. AEC. Somebody else give me a different one. EA would give me like a segment. It's got to be 3 letters. Say it one more time. Angle CEA. Good job. So it's got to be 3 letters. Vertex has got to be in the middle. Good? Okay. So we go to angles. Angles are measured in, ready for it? Degrees. I know, you're shocked right now, aren't you? Whew. 2 things you need to know about this. Number 1, notation. If I put an M and then an angle symbol and then the letter, it just means measure of angle A equals 80. It's just a shortcut for writing out measure of. The second thing I need to know is if I extend the rays of the angle, does the measure stay the same? So if I make these look longer, because rays go on forever, so if I continue this on, does how open it is stay the same? Yeah. So it doesn't matter how far out I extend those lines, the measure is always going to be whatever it started out looking like right by the vertex. Good? All right, we're going to classify angles. You guys know these already. What type of angle is this one? Acute. So that is anywhere from 0 to less than 90. So it can't be 90 because what's a 90? Perfect. Okay, then the next one is obtuse goes anywhere greater than, oh, can't spell. If I'm going too fast, you got to tell me because sometimes I go too fast and I make myself not spell. Obtuse goes from 90 to 180, but it doesn't include those, right? All right, what's the last one then? It's a trick question. It looks like a line, but we're dealing with an angle. There it is. Nice. It is a straight angle. So straight angles are when they are 180 degrees. And it'll have that point on it, might make it easier to see that it's a straight angle. If I tie something else back in, what kind of rays do I create when I have a straight angle? Starts with an O. Opposite. Very nice. All right, are we good? Okay, we need to turn to the next page. We need to remember how to measure with our protractor. Okay, when you take your protractor, you're going to find the 0 on your protractor. For me, my 0 is the line above the bottom of my protractor. So figure out where 0 is on yours. You put the 0 on the vertex of the angle. And you line up the edge, right, going straight across from the 0 with a ray of your angle. What I do then is I look at the arrow that's pointing at 0 and I go to the 0 scale. So my arrow is lined up down here on the bottom and it's pointing to the left. I'm going to go all the way out until I see 0, which for me is my outside scale. Then I'm going to count up until I get to where the other arrow is pointing at. So whichever ray you line up on, follow that arrow till you see the 0. It could be your inside scale or your outside scale. It depends on your protractor. Okay, and then we count up, and what do we get to? Approximately. Okay? When I give that to you on a test or a quiz, I give you a little wiggle room. It's about a plus or minus 2 degrees. And what I do is I pick up my protractor and I put it on there and I try to see if I can adjust it. You know, like, well, if I move it just a little bit so it's right on the top of this ray, then can I get there angled? If I put it on the bottom, can I get it? Like, I try to give you the point. Okay? So you just got to be as accurate as you possibly can be. Questions? What kind of angle is that? Obtuse. So one of the other things you should recognize is if you are measuring an angle and it's obtuse, you look at it and it's obtuse, and you're writing down that it is 60 or 50 degrees, do those two things work together? No, you used the wrong scale. You didn't look at your 0. Okay? Questions on how to do that? I think we just answered that, right? what happens there? If we extend the rays, does I change my angle? So if you can't see where it goes, like you got the big protractor, you can 100% take your straight edge and go like that, and then put that protractor back on there and go, okay, now I can see where it crosses. Extending the ray does not change the angle measure. Okay, we're going to do one more thing, and then we're going to have to stop in the interest of time. We want to draw a 105-degree angle. Give yourself a ray to work on. So give yourself something straight. And then take your protractor and line up your 0 whichever way you went. I went to the right this time. So where I find 0 now is on my inside scale. What kind of angle should 105 be? Obtuse. So when I go and I count from 0 to 105 and I put a little mark out here, where 105 is, then I want to draw in using the straight edge, the edge of the protractor, whatever, a ray. And I got to look at it and go, does it look obtuse? Because if it doesn't look obtuse, I use the wrong scale. The last thing you want to make sure of when you draw them is that you put arrows at the end. And one last thing, and then I really am going to stop. Some of you may have drawn a straight angle on there and then use your protractor to put it in. If you do that, I need a mark in the angle so that I know which one to grade. Okay, you don't have to do it that way, but if you did, you need to give me something that tells me which one to grade. All right, on the homework, you should still be able to do all of it. The only questions that might be of concern are number 8 and number 9. I think you will be able to figure them out if you just draw the things they give you on your picture. But I will also go through the rest of these notes. So we will take care of those questions no matter what. Just know that you can still do all of the homework.